A to D resolution is an important component of signal fidelity on modern oscilloscopes, but there are a number of approaches and technologies that affect visualization in different ways. Rohde and Schwartz talks about how high resolution helps you visualize small signal details in the presence of a larger signal. This is the critical use case. So let's look at how these different approaches improve this type of visualization. The most common technique is a high resolution acquisition mode. This is accomplished by averaging samples that are between points in the display to improve accuracy and reduce noise on the display. It's important to note that this is done on the deep memory points within a single capture, preserving the signal integrity of the individual trigger event. So this is different than an average mode that combines data from consecutive trigger events to provide an average over time. Both Rohde's RTB2000 and Regal's MSO5000 series have a high-resolution acquisition mode. Although there are differences in sampling and memory depth, they work in the same way. Rohde also uses their custom 10-bit A to D to improve the actual resolution of each sample to make these details clearer. One of the focuses of Regal's custom analog front-end ASIC, which is part of our Phoenix chipset, is improved dynamic response. This makes it possible to zoom in and analyze small signal details without introducing additional errors from saturation of the front-end components. Let's compare how we can view signal details between these two instruments. Let's look first at the RTB2000 running firmware 02.202. Rohde's RTB2000 gives you a clear view of the signal detail when you have the entire signal on the display. We can go into the acquisition mode and change to high resolution, and that reduces some of the noise, clears up the signal considerably. Now the next thing an engineer would do to view this signal would be to zoom in on it. Now as the engineer zooms in, we see that the overdrive saturation on the front end really completely distorts the signal that was there originally. Let's look at how this is handled on the Regal. So on the Regal, we've started with setting up the color grading on the display mode to view that signal most clearly. Now we can go into the acquire menu as we did on the Rohde and switch to high res mode. This reduces some of the noise in that front end signal. Now let's zoom in. So when we zoom into that same 20 millisecond per division or 20 millivolt per division range, we can still clearly and accurately see that signal event as soon as it comes down to that first level. This is really about the improved dynamic response at the front end, the analog front end on the ASIC in the MSO5000 series. Gives you that improved initial response time and makes it easier to zoom in on signals and view them as you would like to view them in normal mode. Combination of the dynamic response, sampling memory, and acquisition modes make the Regal MSO5000 a great oscilloscope for signal fidelity and high accuracy measurements.